Okay, well, let's do the easy one. Hey guys, when you're looking for this, this is the function, and I want to, guys, I want to find the derivative function. It's a function of the derivative. So you get another function, and you're just going to graph the slopes. So if I look at the slope of this function right here, it looks like it's maybe -2, but it's a constant, right? So it's going to be down here. What about at that corner? I don't know what it is, right? It's undefined. What about over here? Still not defined at the corner. But that should be your derivative graph, which would match with, I don't have these memorized, let's see. Oh, E. Okay, so that wasn't too bad, was it? What'd you get for B? Does everybody agree? Okay. Okay, C. What'd you say it was? D? Because the slope is always positive. What do I look for? I look for the positive signs, and I look for the zeros. That's 0. And then it becomes positive again. So it's always positive. What letter was that? D. Okay. How about D? Did you get that one? You did great. Okay, what about this next one, E? I look for where the slope is 0. That's right here. Slope here is 0. What's true about the slope on the left side? They were kind of numbers. They're positive. So my derivative function will be up here, and then what happens to my slopes here? They're negative. It's got to come back to 0, and then here they turn to positive again. So it looks like a parabola. What letter was that? What was it, F? Now, this one's trickier. I'm going to also look for the zeros, which is right here and right here. These slopes are positive as I come up here. So it's going to do this. But now the slopes become negative. What is special? What's happening at the origin? There's a break in the graph, in the derivative graph. This is 0. And then it's getting negative and more negative and more negative. What's it going to? You guys said straight line. All lines are straight. It's vertical. Vertical. What about here? This is still a negative slope, isn't it? So it's going to come up to 0, and then the slopes become positive, which would be J. I'm just looking for shapes. Well, G is also tricky. What's true about the derivative at the origin here? It does not exist. In fact, the slope on the left is positive, and the slope on the right is negative. How do you see that different from H? That's smooth. This is continuous. Its derivative is discontinuous. This derivative is continuous. This is a smooth curve. So it's going to be 0 here, it's going to be 0 here, and 0 there. So it's going to be negative, right? Positive, and it's going to come back to 0 and go up. So it looks like that. What is this going to do? It's positive till I get here. Sorry, said that wrong. Sorry, negative slope till I get here. It's going to do this. What's it going to do here? Negative slope till I get to the 0. Which one is that one? Is it C? Is it getting a little bit easier to see what's happening? I look for the zeros, and if it's positive or negative. If the slope's positive, my graph is above the x-axis. Okay, what was H then? I'll trust you. This one gets a little trickier. What do you think that one was? Does everybody agree? Are there questions? Let me see what A looks like. Nice smooth curve. That's a nice smooth curve. You're going to get a nice smooth curve. Now this is an asymptote. It's going to 0. Looks like. And that's why J, K, and L are hard, because we have asymptotes. This doesn't get to the slope of 1, but it gets pretty close. So here's my asymptote for the left side. So it's going to be getting close to that. On the right side, it's going to be a what? Positive or negative slope? Negative. And it's going to get pretty close to that. It's going through 0 here. Now, the difference between this picture and this picture is very slight. Grant, how do you know which one's which? What's true about the slope? It's getting bigger and bigger and bigger, and then it's going to go back to 0. So it's going to have a little bump there. Is it above that? Oh yeah, it's even bigger than that, isn't it? So it's going to go above that line and come back to 0. What about the slope here? It's even more negative than that, so then it's going to come back like that. Because it's steeper. Let's do the positive because it's easier to see. This positive, this is a slope of 1. What's the slope there? 2. So it has to be above this 1. So which one was that one? That would be a weird looking one. That's I. That one's hard. You really have to think about it. But they're kind of fun, like puzzles, right? Okay, this is similar but not quite the same. What's the answer to K? It's what? It's B. So I and B look the same a little bit. B just doesn't have that little bump there. So this is B, and no choice for the last one to be, but what is it? H. Isn't it H? Yeah. The slope here is 0, or it's getting close to 0, and it's negative, so it's coming from this side. This slope is positive, it's coming from that side. This is 0. Let's look something like that. Where's H? Yes. Okay. Feeling better about this now? Now, what about questions on your homework? Out of 3-1. We will have a homework quiz on Tuesday on 3-1. Right. 17. We had questions before 17. I like 17. Let's do 17 first. Why do I like 17? Because I see this on the exam all the time. So, now I don't have a video for second hour. This is a video here, but some of the problems are worked out. A lot of the problems are worked out. 17 says f of 2 is equal to 3, and f prime of 2 is equal to 5. Find an equation of the tangent line and an equation of the normal line. What's the equation of any line? Y minus y1. Hey, Grant. Shh. We're doing math. Did you get number 17? Okay, we got to get 17. Why? Because this is an easier version of what's on the exam. I don't want any surprises on the exam. We practice getting ready now. So, and you could really solve for y. It's equal to y1 plus the slope of x minus x1. Doesn't matter. Both are okay. Okay, Grant's going to help me with this. It's y minus y1, I put parentheses in, is the slope x minus x1. And you have to put a number in for slope. I never want to see a variable. I saw some variables in my BC class. What's the y value? 3. What's the x value? What's the slope? 5. Done. Done, that's it. That's all it's asking. Don't do y equals mx plus b. That's too hard. So what's the normal line look like? How about the normal line? What's the opposite? So it's y minus 3. It's the opposite reciprocal. So it's what? Negative 1/5. What? X minus 2. How could it be that easy? It is. Because it says f prime of 2 is the slope. F prime is slope. That's what the question is. Thank you for the question. Okay, shh. What? Number 3. So you should have your homework out right now if you have not done it and be working on it with me. You're going to have work time this week. There's not that much to talk about in section 3 too. So if you haven't done it at all, you should have your books out and be working. Not doing homework is not an option.
Is it 2?
I don't know. I'm going to do this form. I'm on 3-1. Oh, 3, the quick review is hard. Is that the one the question is on?
No, it's in the second one.
This one.
Yeah.
Okay. They tell you which form of the definition they want you to use. Now you have to be able to recognize those on the exam. So A is -1, so f prime of -1 means I'm going to find the slope at x equal to -1. So it's the limit as h goes to 0, and it's f of a plus h. So it's 3 minus -1 plus h squared. That's f of a plus h. Did I do that right? I think I did. Minus f of a. It's 3 minus -1 squared. Do I need parentheses around that? Yes, this is the case of the invisible parentheses, because it's not the opposite of the 3 or the opposite of whatever this is. It's the opposite of the whole thing added together. You have to add before you subtract, order of operations. Okay. -1 plus h, because it's a plus h. What's a? What's a? It's -1. A is -1. That's -1, so that's what you substitute in. Well, I don't want to, I'm going to clean that up a little bit before I do it. Guys. Okay, I'm going to fix this a little bit. It's 3 minus, and that's h minus 1 squared because it's easier for me to square. I'm going to mess it up the other way. Minus, and then this is 3. Do I need these parentheses around the -1? Yes. So this is a positive 1 when I square it, but now it's going to be minus. I could do that, but let's see what happens here. All over h. I can cross out the 3's. So it's the limit as h goes to 0, and it's 3 minus, parentheses, h squared, what's the next term? Minus 2h plus 1. You should be able to multiply out a binomial. We've squared things a lot of times. We should be getting quicker at that. Minus 3 minus 1. So why don't you just make it 2? Oh, let's see what happens. I could. It doesn't matter. So it's 3 minus h squared plus 2h minus 1 minus 3 plus 1. What's going to happen?
Don't you have to multiply the -1 and the parentheses?
I did. -1 is a positive. Okay. Are we okay to skip this next, go right to the next step and factor out the h? Getting tired of doing this, aren't you? Why do you think I can do it so well? Because I've practiced a lot. You need to practice as well. Because if you practice, you recognize it. It's minus h plus 2 all over h. What happens to h's? Substitute h equal to 0 in it, and I get 2. Now let me do this my shortcut way. In my head. That's correct.
Wait, what was your question?
The derivative of this, f prime of x here, is going to be equal to -2x. A is -1, so it's going to be 2. I'll let you wait. You'll just have to wait till Tuesday. What can I say? Some people know the rules. Julian, you know the rules, right? The shortcuts? From physics? Yeah. What? Right here? This is f of -1 plus h minus f of -1. Yeah. So you put this in. You put this in for x. Okay. Shh. Are we ready to go on to number 11? Because it's f of -1. What's f of -1? 3 minus a -1 squared. I just followed the directions. Yes. Yes. And this isn't going anywhere. This will go up on Schoology if I remember to do it. You can email me and tell me I forgot to do it. That won't help until the next day because I can't get to it from home. Okay, ready? Well, we're going to do 11. Yeah, we can. And then we did 40. Okay, 11. Hey, guys. Now, I think part of the problem is this, knowing what that's saying. We have to learn notation. We're learning a vocabulary in this class. And it says to use this derivative form at the indicated point. Well, guess what? They didn't give us an a value. So we're going to have to do this at a. Now, that's just the change in the y's. Oh, it's going to be at any x value. We're going to come up with a formula. I already know the answer is going to be 2a. Because you're going to need to recognize this. Plus, this isn't that hard. Now, sometimes one form of the derivative is just easier to work with than the other. The other, we had to do c plus h and square. I kind of like this one. So this is saying find the derivative at x equals a. So it's the limit as x approaches a. It's f of x. What's f of x? Minus f of a. That's f of a. Substitute in a, it's a squared. I know you're thinking, it can't be that easy. Yeah, it is. Over x minus a. Now, do you recognize something about that fraction?
Why is it a? Well, it's 1. It's 1.
Because it's f of x is x squared. What's f of a? A is a. A squared. Okay, shh. Algebra's easier. I don't have to know the arithmetic. Yes? Okay, if I put in a, I get 0 over 0. So what can I do to simplify that? Can't take out the square, but I can do what? Factor it. We should recognize this as a difference of two squares. How do you recognize it? By doing lots of problems. When you get into the exam, you want to have done lots of problems so you don't have to sit and waste your time thinking too long. Because you're going to have to do that. It's a time test. What happens to the x minus a's? They go away. Substitute in a and you get a plus a, which is 2a. What was the next one I'm looking at? 31. Equal to a, you get 2a.
Yeah, both.
Oh, okay. We did a different one in the other class. So if you want the other one that's a one-sided derivative, you can look there. That was 40. We can do it too. It's broken. You can try and use it. Okay? This one's a little harder to graph, but we can graph it. Let's look at this. Let's look at this graphically before we try to do this. It says show that there's no derivative at 1 by looking at one-sided derivatives. So, well, I'm going to first graph it. Now, what does y equals x squared plus x look like? First off, what's the shape? It's a parabola. I certainly would like intercepts. That would be nice. How about the zeros? The zeros occur when y is 0. Where does that happen? Sorry. X equals 0. X equals negative 1. So it's a parabola. And I want the parabola until I get to 1. And I could find f of 1. What's f of 1? So that's 2. And it even gets included on that side. What, on the right side now, she's a different color, she's green. What is f of 1? Well, I really don't know f of 1, but I can find its limiting value because I'm going to get really close to 1. So if I put 1 in there, I can see approximately what it is. What's f of 1 on this side? Approximately equal to. It looks like it's equal to 1. And it's not even including 1. So it's not differentiable here. And what's the slope, by the way? Over 1, up 3. So it's a line. It's not differentiable there because what's the problem? There's a jump. What's the math word? It's discontinuous. You can't find a derivative at a point if you don't. You got to have the other side. You can't have a break in the graph. And the thing is, you could find the slopes. The slopes might be the same. Now let me use my shortcuts to see. Does anybody know the derivative of this? 2x plus 1. If f of x equals x squared plus x, f prime of x is equal to 2x plus 1. We will find out Tuesday. You just have to not come to school Monday and have to wait till Tuesday. So what's f prime of 1? Okay, guys? This is an excellent question here. It's 2 times 1 plus 1 or 3. Okay, guys? If you're having your conversations, please don't. First off, my throat's sore. Okay. What's the slope? Now, this is the slope on the left side, right? This is the left slope. We don't have to do any calculus to do the right slope because that's just a line. Do we? What's the slope on the right side? 3. The slopes match. But the problem is there's a break in the graph. And for you to be able to have a derivative on the graph, any point on the graph has to actually exist there. You can't have a discontinuity. So the fact that it's not continuous is the reason why it's not differentiable there. This is not continuous because f of 1 does not equal the limit as x approaches 1 from the right-hand side of 3x minus 2. And you would have to give me the numbers. F of 1 was 2, and this limit was equal to 1. And that's the reason. Okay, we'll hit on that again tomorrow. Because there's a discontinuity there. For you to find a derivative, the function must be continuous. Not to say that that will guarantee you can find a derivative, because you can't. There's no derivative there. F prime of 1, let's do math language, does not exist. So you've already learned a lot of math vocabulary. Let's go learn more. Okay, is that okay? More questions? Function must be continuous for a derivative to exist. Be careful, it doesn't work the other way around. So graph helped me see that. So tomorrow we're going to talk about where can you find derivatives, where can't you? And we'll summarize it. Are there other questions or is that it?
7.
Oh, 27 is a good question. They did not ask me that question. Now, I know you guys have things to do. You had work time in class, but, I would like to have you work 30 minutes outside of class. I think that's fair. And there are times when it's not going to be fair, and we'll talk about that. Like, you have a zillion things going on, and I'm very understanding of that. But as a general rule, I think you can put in the time. And the way you are successful in calculus and on the AP exam is to practice. Now, we can't do too much with this. Basically, I'm asking for the antiderivative. The derivative of the function, which is the slope of the function, to the left of -1, has a constant slope of 1. I'll just draw this. Okay, so why don't I put in my -1? I'll put it in here, because that's my dividing point. Now, this is f of x. If the slope is equal to 1, and I have to go through f of 0 is -1. I want a constant slope of 1. Did it say it was continuous? Probably. Oh, it didn't. Oh, yeah, it says continuous. It says, I know, slope of 1, which means it would look, there's a whole family of lines that look like this. I have to have things connect. Well, let's do the right side. What's the slope on the right side? -2. So I'm going to go over 1, down 2. I'm going to go over 1, up 2. So this is going to be here, open circle. So that looks like that. Is that slope -2? Anywhere on that line. Isn't the slope -2? Yes, this is 1. Well, this is anchoring our line, and I'm going to take one of those lines and put it over here. Maybe. I bet they're all tied together. Yes, there. I'm going to take one of these lines and put it over there. And I want it to match up, so it's continuous. Well, except I missed something. So it's got to go right there. It's got to be, there's got to be a continuous thing there. Oh, f of 0 is -1. No, that still doesn't give me f of -1. So they have a little problem in the book. No, it doesn't say that. It just says the slope is there, and they have to match up. So we'll just connect the dots. It's okay, because I don't really care what happens there. This is m equals 1. No, this is the only thing that works. So if they're going to be continuous, you have a slope of 1, a slope of -2, and this could go anywhere. This graph could be here, anywhere on that line, but they anchored it on the -1. Pardon? They anchored it here. This is going to be an important idea. I'm just going to leave this for you to think about. Is that it? You need to be doing, even if I did the problems in class, you need to go back and do them. Make sure you understand them. And then you need to check your answers. The answers are all online. If they're not, let me know. 24. Grant hasn't even done 24. Ooh. Okay, this is the graph. F of x is equal to x times the natural log of x. And trust me, there will be lots of exponentials and natural logs on the exam. It will be all e to the x and ln of x on the exam. So get used to them. And it says, from what you know about the graphs, of functions 1 through 5, pick out the one that's the derivative of that function. So it's just like what we did on our activity today. I like to find my slope as 0. This is 0 here. What's true about the slopes here? They're negative, right? But it looks like it's almost vertical there, so I'm going to guess it's going to be something like this. And then what's true about the slopes from here? Positive. So which one matches that? Oh, I have to look at the functions. Well, obviously, it's not a sine graph. Could be two slopes. What does the square root function look like? It looks like that. So it's not that. That's 3. 2 is the log function, which looks like this. Might be that. Y equals x squared is 4. Doesn't look like that, does it? And 5 is y equals 3x minus 1. So it looks like 3x minus 1 looks like this, which is the best choice, 2. And my original picture is not that great, but if you look at the graph, it's hard to say the way it's drawn, but it's not increasing very fast. So, but the log function increases forever, but not very fast. We could check it, use our calculators, and graph it, and use ndrive. Do you want to do it? You want me to use the CAS? I'm not sure if I know how, but we can try it. So do I. Any old Inspire will work. We do have a whole bunch of other Inspires too. I also know the derivative of that. Okay, where is it? There it is. Okay, so I want to type in x log x. My problem is I'm not sure if I know how to do the derivative. Oops. Didn't like, oh, you know what? I know what I did wrong. Do you guys know what I did wrong? When you do on the Inspire, you have to put the time sign in there. Otherwise, it looks at xlnx as a name of a new function. So I got to go and put the time sign in right here. Yes, and the minute it becomes not italicized, we're okay. There it is. Now, we're going to try to put ndrive in here. Let me see if my menu will do it. It's, I'm going to graph. Okay, I'll type it. I'm not sure it's going to work. The minute I put the V in, it should become not italicized. And then I want a F1. I can just type in F1, comma, X. I believe that's all. I may need 2 X's. Let's do that. It depends on the syntax. So it didn't like the 2 X's. I still don't know what it's doing. But what I could do is I can go back and get it over here, maybe. Add a page, calculator, and then we can assign that to F2. We're going to try this. I'm not very good. Equals. Now I can get this off my calculus menu. And I want F1 there because I don't want to type it in. Okay, comma, X. Oh, okay. I don't know if that's going to do it. Oh, why is that not working? Comma. There it is. Enter. If not, I'll find out. But you could do it on your 84 easily. Ah, you got me. I'm not missing a parentheses, but that's okay. Let's see. You guys, what are you doing? um, I can't even get rid of it. Okay, put off with 84. So I really want to do this. You guys should be having your workout. You should be working while I'm doing this. They don't. Work. Your book. Where's your book? Why? Guys, bring your books. You need to bring your book every day. It's not even a big book. It's a little book. Okay, so x log x, should have just done it this way in the beginning. Is that log? Nope. Where's the ln? Oh, there it is. You guys, you have plenty of stuff to do. Oh, look at that. I already have my derivative set to go. So I can just press graph. Here it comes. Do you recognize that picture? It's the log function. I gotta figure out how to do that. Because these guys have to know. Okay, girls. You should have your book out. You're all done? You're all done? Yes.